Okay, hi. We're here at the Indonesia International Geothermal Convention and Exhibition again. And it's my pleasure to be here at the booth of Casil in the New Zealand area. We're talking with Professor Jim of Casil. So, can you introduce yourself briefly and Casil and what your company does?
Thank you, Carlo, and for the opportunity to actually talk. I'm Jim Johnston, and I am the actual inventor of the Casil technology. It goes back to government-funded research I was carrying out in university, and we have developed and spun out a commercial company, Casil Technologies, to commercialize the technology.
So, can you tell us a little bit about how your technology works?
This is something I discovered quite some time ago. I was always concerned with the silica scale formation and the fact that currently there really isn't a technology that completely addresses the problem. If it did, then we wouldn't have silica scaling. So the present technologies really slow down the polymerization, and they are acidosing, of course, or the use of inhibitors at the front end. I took a completely different approach and developed what is actually a transformational technology, and we capture with our particular dosing reagent the silica that's in the water straight after steam water separation. We also capture some of the polymeric species before they can scale. So our reaction between our dosing agent and the supersaturated silica takes place within a few seconds. And that forms this particular material, which we call nanostructured calcium silicate. And the nice thing about the nanostructured calcium silicate particles is the chemistry is different from silica. The particles don't stick to each other, they don't form a scale, and they don't stick to metal surfaces. The particles then travel and remain suspended in the brine flow. So they flow through binary heat exchangers, or heat exchangers used to extract heat for other purposes, and prevent scaling within the binaries. Downstream, we separate out the particles as a useful calcium silicate product that has environmental beneficial applications. Now, the key attributes are that we can take really highly silica saturated, supersaturated saline brines, which have very high silica saturation indices. We've just done one in preliminary work with a brine in Indonesia, which has a SSI, silica saturation index, of 9.8. We took that silica saturation down to about 0.3, and that's an amazing result. It can't be achieved by any other method. So this is a world-first technology. So that means that you now have a brine, treated brine, which you can extract significantly more heat energy out to generate electricity. So in an existing geothermal field utilization, you can now put another binary unit behind the one you've got there already. So if you put our dosing agent ahead of the existing binary unit, you protect that binary unit from silica scaling. You can then put another binary unit down, and we can take the silica saturation temperature down well below 80 degrees centigrade, which is about the lower temperature of a binary. We can handle any brine coming in. We've demonstrated the technology up to 220 degrees centigrade, and we can lower that temperature down to 80 degrees, 70 degrees centigrade, and take out all that extra heat energy.
So, aside from the opportunity to generate more power using binary technology, and of course, avoiding the issues of silica scaling, are there other opportunities that geothermal companies can get, perhaps in the downstream side of silica removal?
Yes. Well, what our process does is it lifts the pH of the brine, and that puts the pH into the area of passivation, which reduces the potential for steel to corrode. So not only do we stop silica scaling, we also can help mitigate corrosion. Whereas if you're acid dosing, you're lowering the pH and you're actually engendering corrosion. And we can also help mitigate antimony sulfide scaling as well because of that pH. So that's another advantage of the technology. And then we have a product, a nanostructured calcium silicate product, which we've developed environmentally beneficial applications for.
Yeah, it looks like a win-win scenario, really. You mentioned that you've already done pilot tests in DA, and of course you're a New Zealand company, so you've already deployed there. So are there other markets outside of Indonesia and New Zealand that you're targeting?
Yes, very much so, Carlo. We've demonstrated the technology at 4 different geothermal fields in New Zealand, all with different brine chemistry, and it has worked very well in all of those fields. The technology is very robust. Then with the opportunity to test the applicability of the technology in the Indonesian field, which is highly supersaturated, high salinity field, we've just completed that work and that's been very successful. So clearly the target markets are New Zealand and the Indonesian, the Philippines, Japan, and then in the California area of North America, down through Central America as well. In fact, all geothermal fields which have silica deposition problems.
Perhaps an unavoidable question when it comes to material recovery from geothermal brine is that, does your technology interfere at all with lithium recovery?
No, in actual fact, it facilitates the removal of lithium. One of the big problems with lithium removal technology is the fouling of the membranes or the absorbent material used to capture lithium. Our technology takes the silica out of the water, but it doesn't influence the alkali metals, the sodium, the potassium, or the lithium. So you then have a brine which has a very low silica saturation index, but the lithium is still untouched. So you can then put your lithium recovery technology downstream of our technology.
Indonesia still has a lot of potential. So what do you think can your technology provide to help boost this geothermal growth in Indonesia?
The opportunities here are really amazing. The brines here, often high temperature brines, high enthalpy fields, where the silica saturation is a much larger problem. And we eliminate that problem. And so the technology is essentially applicable to any geothermal brine which has a silica saturation issue. And at the IIGCE here, we've had the privilege of interacting with some of the very important Indonesian companies. And so we look forward to collaborative opportunities and a very, very exciting future.